So what I want to do with you guys is I want to go ahead and review how to do standard deviation. It's worth actually talking about right now about the range here. Remember what the range was? Do you remember what the range was? The maximum minus the minimum. I guess I can just write equals to here. Now, what's the biggest number there? 47. And what's the smallest number?
37.
Looks like 37, right? So the range here is 10. Now, I think what's most interesting here in terms of what the range is a measure of the spread, but it is the crudest measurement we have. And the reason it's the crudest measurement we have because it just takes the two extremes. As a consequence, your range is not resistant to bigger or small numbers, to outliers. It's very not resistant. So it is useful, but it's not too useful. It's like it tells you, here's how wide our data is. Now, last class we developed a sort of a definition for the standard deviation. And let me just say, if it's a population, let's assume it's a population, our formula looks like this. So here is our variance. And if you remember correctly, so this is our population variance. And if you take the square root of that, if you take the square root of your variance, you end up with what? What's the square root of your variance? Called the population what? Standard deviation. So if you remember correctly from last class, you have a few steps. Okay. The first step, step number 1, is to find your mean. Yep. Whatever. Now, obviously, I've already made a note for the people who are writing and not writing. Obviously, even though I looked at you twice, it doesn't matter to me. Right? So you're not going to do it, right? And you're taking your time. Like normally, you just open up. It's like it's just, it doesn't matter to you, right? Would I be correct in saying that? What happened? Yeah. No response, doesn't matter. There's I think my phone should be decent large. Oh, these people haven't come back with a thing. Maybe the machines are not working. Okay. So let's find our mean. How do we find the mean? Notice that the symbol here we're going to use for the mean is mu. So sum of x divided by n. So what are we adding? All those numbers. So let's go ahead and do it. I'm going to do it here with my calculator. We take 41 plus 38 plus 39 plus 45 plus 47 plus 41 plus 44 plus 41 plus 37 plus 32. You'll be able to see everything I'm seeing. Divided by how many numbers do we have there? 10 numbers. So carefully take your time and go 41 plus 38 plus 39 plus 45 plus 47 plus 41 plus 44 plus 41 plus 37 plus 32. Do you guys get 405? Which one? Oh, so I missed a whole number? Oh, 42. So it's gonna come out to 415. All right, so let me correct that. So this last number here is a 42. So you guys have 415, right? And what's 415 divided by 10? So that is your mean. Yes. Are you gonna be careful? Be careful. All right, so good. All right, step number 2. Now let's take a look at the formula. The formula says x minus the mean. So we take each x and subtract the mean. Then it says square it. It says add all up, right? Because that's what the sum means, and divide by n. Do you get that? I'll go ahead and point at the board. You take each x, subtract the mean. Then it says square it. Then it says add them all up. And then you divide by 10. And now get you your variance. Fair enough? So it's a lot of steps. So here we go. I'm gonna use a table to do this. So let's do a table. I'm gonna try and make a nice table though. All right. Could it be these people? Could it be them? So you're gonna make a table.
Yes, sir.
So how do you get it done? Do
We
you?
just left a note in this class.
With explicaciones.
If I bring my Sierra to school, you think I get in trouble and do it in class?
No.
X minus the mean. X minus the mean squared. So you make this table. So that's your second step. Would you guys please populate that table? So we're gonna have, I can't see the numbers anymore, so I'm gonna zoom out a little bit. So we have 41, 38, 39, 45, 47, 41, 44, 41, 37, and 42. So we have now the second column, 41 minus 41.5. Notice I put here negative 0.5. Then you have 38 minus, I'll zoom in here so everybody can see it. 38 minus 41.5, negative 3.5. And as you notice, what I'm doing now is I'm finding how far away, let's just call it, let's just say the terminology you want. I'm finding my deviations. How far away each of the data points is from the mean. And so this, what we're trying to do is we're taking into account each and every single number in the data set. Right? Now, guys, what did we say last class when we added up all our deviations? What should we get? 0. It always happens, no matter what. Now we should always check because sometimes we make mistakes. So I'm gonna check. Yep, it adds up to 0. Now, what's the next step in this table? We're going to do what? Square all these deviations. Now, it's super important that when we square all these deviations, we realize that everything has to come out positive, because sometimes you do it in your calculator and you put negative 0.5 squared and it's no good. It comes out negative. So just remember, everything has to come out positive. That's the whole point we're squaring. Because we need to be able to find a number that makes sense for us to use so that we can average this out. What on earth? Oops. So what happened is I'm using this calculator, this phone calculator. You know, sometimes when you press on it, you're not. Look at this. Every time I do something, I get the wrong answer. Squared. There you go. If you press it twice by mistake, it does something wrong. So what's 5.5 squared? 30.25. So this comes out to 0.25. 2.5 squared, 6.25. I'm gonna buy myself a TI-89. That's a calculator I like. Actually, TI-84 is really nice too. Look at this, 4.5 squared. All right, so now we have to add up all these. And this here down here, we call this down here, when we add up all these others, the sum of squares. Some books like to say this is S of X. So let's add them all up. Hopefully I can do it properly here. 0.25 plus 12.25 plus 6.25 plus 12.25 plus 30.25 plus 0.25 plus 6.25 plus 0.25 plus 20.25 plus 0.25. I'm getting 88.5. 88.5. So now you filled out this table. So step number 3 is find the variance. So what happens is when we did the sum of our deviations, we got 0. But the idea was that we would divide, we will find an average of these deviations. So we squared it, it all came out positive, and then now we're going to do and find our variance. So we're going to take whatever we found there, and we're going to divide it by n. What's n here? So there, you divide this by 10. And number 4, step number 4, we're going to find our standard deviation, which is what we do is square root the variance. So we're going to square root 8.85. Try to keep, sometimes you don't have nice numbers for the variance. So you round the variance and then you square root it. But if you have it in your calculator, keep the best representation of that variance in your calculator. So this is going to be approximately 2.97. You dressed up to school today. What did you dress up as? Huh? Yeah. Yes. Be careful. The standard deviation. Now that is how we do these problems. Now I want to, once you guys, because I know some of you are writing. Yes. Question. Guys, I know it's boring. I know it's Tuesday. I know you guys are under motivated. Yes.
Another problem because I
Yes.
don't understand.
I know because you were mentioning.
Wait, this is the same lesson from last time?
Yes.
Oh, okay.
You still don't understand. No, some of you will never understand standard deviation ever in your whole life. You will never. Now, all right. So here's the thing. Again, I'll go through another problem. But I gotta make a little comment about the difference between population and sample. I'll make it now, and then we're gonna go ahead and do another population one, and then switch it over to a sample. It's a very small difference. What we're trying to do is we're trying to develop what standard deviation is we're trying to average out the spread of each of the numbers from the mean. So we find the mean, we find the center, and then we take the distance of each of those numbers from the center, we list them down, we add them and divide by the total amount of numbers and then square root it because we had to square them. That's what happened, essentially. Right, so I'll wait till some people are still writing, and then we'll just do another problem and I'll explain it again. And hopefully in the next 20 minutes or so, I'll get done with that problem. Now, I need to mention something. If this were a sample, then this part here, called the variance, we would divide it by n minus 1. So if when we started the question, instead of population, I would have put sample there, then the problem stays the same. But, so watch what happens when it's a sample. If it's a sample, look what happens. I'm gonna write here sample instead. Right? If it's a sample, the formula becomes this. We don't use mu anymore, we use x bar. This is n minus 1. This becomes s. It also becomes s. That's a really bad s. I'm sorry to hear that. Right now, I'm contemplating whether I'm gonna tell him something, but I don't want to because I feel like I'm gonna be picking on him. I don't want to pick on him. So that changes to S. And now when you find your mean, this becomes X bar. It's the same thing. Nothing changes on your mean. You see what I'm doing? I'm just changing symbology. Make your table. Your table is all the same, except we're doing X bar now, right? X bar, right? So your table stays the same. When you add it all up, everything stays the same. But now the only part that changes is when you do step number 3. When you do step number 3, this part right here, you're not going to divide by 10, you're going to divide by 9. This small little change. And that's going to change this number a little bit. that little change, and we write S now, 8.85 divided by 9. That's, oh my gosh. Is that right? 0.98? No, that's wrong. 88.5 divided by 9. 9.83. Now notice it says 9. Yeah, but I did it again. 88.5, right? Divided by 9, you see it? Or what do you mean? Okay, I had done it wrong before. So 9.83. Now notice it's 9.83 repeating. If you take the square root of 9.83, it's slightly different than if I take the square root right there. Like if I left it in the middle of the calculator, and then I just hit square root, I get a better answer. So if you square root 9.83 repeating, if you square root that, which obviously this is still an approximation though, you get approximately 3.14. So I would say approximately 3.14. Now, what was the answer previously for your standard deviation? What was it? Now, if it were a sample, we get slightly different, 3.14, because we had to do n minus 1. The only difference between sample population is that we divide by 1 less than the total number. Okay, fair enough? Does that make sense? Okay, so now I want you guys to try doing this. I'll zoom out. I'm gonna give you some other numbers. Can you see that? Can you see those numbers? Here, I'm gonna go ahead and do some other numbers. So let's say 20, 24, 31, 19. And it's not that many. I'm not gonna give you that many because I don't want you guys spending eternity doing this. And 15. So you have 1, 2, 3, 4, 5 numbers there. Okay, I'm gonna stop the recording temporarily. So I'm gonna pause it actually. Pause. All right, so there we have, right there, we have 5 numbers. The first step is we're gonna find the what? The mean. So I'm gonna take 20 plus, and we're gonna say this is a population, plus 24, plus 31, plus 19, plus 15. And we're gonna divide that by 5. So it's gonna be 109 divided by 5. So your mean is going to be 105. So I'm gonna write down the formula. 105 divided by 9. By 5, sorry. Why am I thinking 9? There you go. That's what I was thinking. 109 divided by 5, which equals what? And do not round this. And so now we found our mean. What's the next step? We're going to create our table. You guys are wonderful. I'll take back what I said about being untalented. Guys, it's an attitude, guys. It's an attitude. That's all it is. You change the attitude. And how do you change the attitude? By practicing it. And you'd be surprised how much you can get done. And it just takes a while. A few years of practice. And the failing. So what's 20 minus 21.8? And what's 24 minus 21.8? And what's 31 minus 21.8? And what's 19 minus 21.8? And what's 15 minus 21.8? And if we add all these up, what do we get?
0.
Make sure to verify you do get 0. I'm gonna go ahead and verify here in front of you guys. 1.8 negative plus 2.2 plus 9.2 plus 2.8 negative plus, and then you see plus 6.8, oh no, 0.8 negative, we get 0. Good. What's negative 1.8 squared? Has to come out to 3.24. What's 2.2 squared? 4.84. What's 9.2 squared? 0.64. What's negative 2.8 squared? 7 point? And what's 6.8 squared? 46.24. And now we add up these. This is called our sum of squares. Add them up. What does it add up to? 146.8. Does everybody concur? Is that what you guys got? 3.24 plus 4.84 plus 84.64 plus 7.84 plus, oh my gosh, look what it did. Because one of the decimals didn't come out because it's a touch thing. 3.24 plus 4.84 plus 84.64 plus 7.84 plus 46.24, 146.8. And now we're going to find, what's the next step called? Find our what? Our variance. So we take our sum of squares and divide it by n. What's 146.8 divided by 5? All right, so I'm going to go ahead and do it here. And that's actually a nice number. Don't mess with it. 29.36. Leave it like that. And what's the last step? We're going to go ahead and square root 29.36. And what's the square root of that? 5.42. So approximately 5.42. So this is our standard deviation. On average, the numbers are 5.42, whatever units is from the mean. That's what we say. This is the average spread. The smaller that number, the less spread out your data is. The bigger that number, the more spread out it is. Now, if you were to do this as a sample, what is the only part that changes? Do we divide by 5 or divide by 4? Yes. So if this were a sample, bless you. If this were a sample, and I should have, if this were a sample, then I don't like the thickness of that right there. Give me 1 second, make it a little bit thicker. So if this were a sample, then this is the same, but we change the symbol here. We call this X bar, and we don't use big N, we use small n. All these become X bars. X bars. Right? Everything stays the same so far. We just change the symbol, the notation. Now here, instead of sigma, we have an S. Now this becomes this. But now this part changes. It's not n, it's n minus 1. So this is divided by 4 instead. And so we take 146.8 and divide that by 4, you get 36.7. So that's if you're doing a sample, 36.7. And now you square root. It's called X bar. It means the sample mean. The other one's a population mean. So, and so what's the square root of 36.7? 6.06. So approximately 6.06. So now your standard deviation is bigger. It's more spread out. Okay. All right, wonderful people.
Is that gonna go on the test?